Okay, we have a full agenda. Shall we get started, Ben?
Yes, let's get started.
Okay,
So this
hello.
is, yeah, go ahead, take it over.
Hello, everyone. This is the Security Area Advisory Group, kind of SAAG. We have kind of a short session here. This is Roman Dinidu speaking with my co-chair,
Ben Kadok.
Okay, why don't we get started here? Just to highlight, we have the Note Well, which you've seen before. If you have any questions, please don't hesitate to ask us. We can clarify. We've built an agenda. We built an agenda around first starting off with what is the work that's happening, going back as far as IETF 106 if needed. We have something a little special this time because we haven't had a chance to get together. We wanted to highlight work that is nearing completion or has completed. So we're going to talk about some of the things recently done in DOTS. Then we have a facilitated conversation we'd like to have around PKI versus pinning applicability that we've already started off on the mailing list. And then with the time remaining, we'll be talking about BCP 72 updates. Would anyone like to bash anything on this agenda? Okay, if not, we'll move ahead with that and do lightning round on working group reports. We won't talk about working groups that have sent reports to the mailing list, and thank you for all of those that did it. And in terms of version control, this slide deck is as old as the reports probably made about 15 minutes ago. So ACE reported, Acme, COSI, Curdle, DOTS, EMU, GNAP, I2NSF, IPsec-ME. Is there something we want to say about Kitten?
I thought that Kitten did send mail. Yeah, they sent mail, so.
Okay, we'll keep going. We probably just have a version issue.
Yeah.
Okay, Lake, Lamps, Mile. Is there something we'd like to say about Mile?
Probably keep going through the slides and we can come back if someone
MLS, it makes sense, Ben. MLS, OAuth. The next meeting is, I believe, on Monday as an interim on the usual drill of kind of doing something regularly. But if Rafat or Hannes want to say something at the end. Privacy Pass, RATS, SACM, Sec Dispatch just met. Sec event, if Dick or Joran want to say something later. Suit, TEEP, TLS, Tokebind, if John or Leaf want to say something. Trans, Melinda or Paul want to say something. And here we'll pause for those working groups that did not have a report if someone would like to come to the mic to talk through anything that's happening. And Ben, if you could help manage the queue, I actually can't see what's happening since I'm flipping the slides.
Yeah, I will drive the queue. So Yaron, you should send audio as well.
This week, in fact, we were going to shut down the working group. However, we found out that there's a lot of interest in the subject identifiers document. So we are keeping on and working on that document. Thank you.
Great. And just a note or reminder to everyone that sometimes it will take a few seconds from when you start sending audio to when the stream is actually making it to everyone. So if you're introducing yourself or something in the first few seconds when you're speaking, that will help make sure that your content gets through. All right, Paul, go ahead.
Hi there, this is Paul for Trans. Is this long enough? I hope so. We did not meet. We're working on one document, the BIS document for RFC 6962. There's three members of the ISG have discussed items open, and it's my job to chase them.
Well, I hope you can find them in GatherTown. I don't know if everyone has been there, but it's the closest substitute for the hallway that we have. So I do believe we got some other reports from some of the groups listed here. I think Utah and CFRG I remember seeing. And of course, we'll be hearing a little bit about Model T later in the deck. Karen, you're up.
I was just going to mention I sent a late report on NTP as well for its security-related items.
Yes, thank you. Okay, I think that is probably all we're going to get from the reports. So let's move on to the next item. Okay, so I guess this is mostly me, so just some other things that happened in the SEC area to call out. We do have a couple of AD-sponsored drafts that have been making their way forward after perhaps a too long hiatus. My document queue has come up at the open mic. So there's the security TXT document that everyone remembers the pretty long set of IETF last call comments for, but we are working our way through those, and I've had some responses and feedback from the authors on the SAG list for my summary of those comments, and it looks like we're going to be able to move forward with that and send it to the ISG pretty soon. And then there's also the numeric IDs set considerations document that I won't talk about right now because we have a separate item later. Other things going on is that we have some work underway to reopen the Open PGP working group. We've seen some new implementation is coming up and interest in doing specific interop work and getting the algorithm updates in place that we had tried to do the previous time around. And we'll also just highlight this link on the slides about some list of typical security-related issues that perhaps Roman and I see a lot when we're reviewing the documents. And that can serve both as a guideline to, say, sector reviewers, but also as a guideline to authors to be on the lookout and hopefully fix things before we see them. We always like that when the document comes in, it does not have the issues. So next slide, please. And we also wanted to throw a big thanks out to the sector. These reviews are really helpful to us, and they are helpful to authors as well to get some feedback a little bit in advance of the actual ISG tall chat. And of course, the earlier feedback is always good to get the documents improved before more people see them. So I just spend a moment to thank everybody. Hopefully we didn't miss anybody and not put your name on the slide. If we did, we apologize. We're not trying to omit anyone, just to make sure that people get the appreciation they deserve. So thank you again. Next slide.
Yeah, I just really want to repeat what you just said, Ben. I mean, thank you for your service, for all those that do the reviews. They're an incredible help to the community and an incredible help to us as we help process documents during the IESG review.
Yeah, definitely. All right, so Tiro, you are up. Do you want to join the queue? You are sending audio, so we should be able to.
Hey Ben, can you hear me?
Yes, I can hear you.
Hey, can you start?
Yes, please go ahead.
Yeah, floor is yours,
Hey,
Tiro.
hey, hello everyone. I'm Thiru. I'll be presenting DDoS Open Threat Signaling overview. It's part of DOTS working group, and this working group was formed around 6 years back, and we have made tremendous progress in various specifications. So I will go over some of them. Next slide, please. Before I jump into DOTS and what DOTS does, DOTS is created especially for DDoS attacks. As many of you may be aware that DDoS attacks have been increasing in the last few years. Enterprise networks, content providers, and ISPs are among the top targets for DDoS attacks. And in the last few years, the attacks have become much more larger and much more sophisticated. And nowadays, if you see, just like software as a service, DDoS is also offered as a service for attackers, and they leverage millions of bots across the globe to attack a specific target. Next slide, please. For instance, nowadays, if you see, there is a tremendous growth in the number of IoT devices, and many of these IoT devices unfortunately have vulnerabilities, and malware typically take advantage of these vulnerabilities and infect these devices. For example, Mira is a very popular botnet which is used to launch DDoS attacks on targets, and recently, if you see, the attack scale has reached close to terabits per second, and it's growing every year. And the biggest problem is that many of these owners of these IoT devices don't even know that these devices are in fact infected, and they are used as launch pads for attacking targets in the internet. Next slide, please. There are hundreds of DDoS attacks. I'm not going to go all of them, but just to say that the attack happens from layer 3 to layer 7. It could be a DNS amplification attack taking advantage of large DNS responses. It could be just a simple SYN flood attack. The most challenging ones are the ones that happen after the TLS handshake is completed, which could be just sending garbage data or sending partial requests to the HTTPS server. Next slide, please. What is the problem with DDoS, right? DDoS is a major problem because of the strategies that are used by the attackers to target different victims within a network, or targeting the entire network itself. And there is a need for automating the DDoS attack mitigation, because the attack could happen at any time. It could be a volumetric attack. It could be targeting the entire network or a specific resource within the enterprise network or content provider network. And there is a need for automating DDoS mitigation so that immediate remediation could be taken, and good traffic can still be processed while bad traffic is blocked. Next slide, please. For instance, if you see last year, a South African ISP was brought down for almost a year, and there's been discussions among several ISPs for the need to automate the DDoS mitigation strategy so that they can effectively sinkhole the bad traffic, and then allow these ISPs to function for their customers. Next slide, please. What was the need for DOTS is that today, if you see, many DDoS mitigation providers and security vendors do offer DDoS detection, DDoS mitigation, but they're all using proprietary techniques. For instance, if an enterprise network is getting attacked today, it's supposed to use proprietary protocols to talk to an ISP or a third-party DDoS mitigation provider, which creates vendor lock-in. And the existing protocols that were used a few years back were not resilient to work under extreme hostile network conditions. For instance, a scenario where there is a large-scale DDoS attack, the entire incoming link would be saturated, and there is no way that these messages would reach the DDoS mitigation provider. So the working group, when it got created, we went back a step to decide what are the requirements for DOTS protocols to function, and then we started working on the protocol. So it took a while for us to figure out the right requirements, which were collected from various ISPs, security vendors, DDoS mitigation providers, and then the work started for building protocols based on these requirements. Next slide, please. Okay, so what is DOTS? DOTS stands for DDoS Open Thread Signaling. It's a standard-based approach for real-time signaling of DDoS-related.
We lost your audio for a bit, so you're on the progress of the process.
Yeah, my Meet Echo just crashed. So
okay,
hello,
you're
can
back
you hear me now?
Yes,
Okay.
we can hear you.
Sure. So DOTS is a standards-based approach for real-time signaling of threat-related information between the target network and the DDoS mitigation provider, so that it completely automates the way DDoS attacks are handled today. Next slide, please. Before I jump into the protocols, I thought it's good to explain how the DOTS architecture looks like for you to get an understanding of how DOTS entities are involved. So target is the target network, or it could be a target server that gets attacked. DDoS client could be typically your DDoS mitigation, on-premise DDoS mitigation, or it could be a DDoS detector which detects DDoS attacks within the network. And then the DOTS server is the one which actually provides you, it's like an SDN controller which Switch, which is actually taking these mitigation requests from the DOTS client and programming the DDoS mitigator to start scrubbing the traffic coming to the target network. Next slide. Relay signaling is a very similar concept that many of you may have seen. It uses DOTS gateway. DOTS gateway is very similar to SIP back-to-back user agent, which is a logical concatenation of a client and server, so that the gateway can aggregate the requests coming from DOT clients and relay them back to the DOT server. Next slide. So if you see a traditional setup of an inbound DDoS, an enterprise network would have a DOTS client. It could be a firewall or an IPS or a DDoS mitigator that is there deployed on the enterprise network. When the attack is overwhelming and the DDoS mitigator cannot handle the traffic anymore, it can send a signal back to the DOT server in the ISP saying that, hey, it needs help, and the DOT server basically starts programming the DDoS mitigation mitigators to start scrubbing the incoming traffic. As you can see on the left side of the screen, there is a home network and CPE, and there's a DOTS client. It's an interesting scenario that nowadays we see many of these home networks also getting attacked by DDoS attacks, and I will go over home network scenario in a couple of slides. But it's interesting to see that even nowadays home networks are a target for DDoS attacks. Next slide, please. Recursive mitigation is an interesting concept. Imagine if the attack grows beyond the scale of the ISP and it is not able to handle the attack, then it can basically signal the upstream transit provider saying that, hey, you need to help me out, and you need to start scrubbing the traffic, and then the transit providers DDoS mitigation DDoS mitigators kick in and they start scrubbing the traffic and start blocking all the bad traffic. Next slide. As I was saying in the previous slide, home network is an interesting case. That home network could be both, could be attacked, and home networks are typically used as launch pads for launching DDoS attacks on targets, especially because of vulnerable IoT devices. That's where we have an interesting draft where the DOT server in the home and the DOTS client in the ISP can coordinate and identify the actual infected device within the home which is launching this attack, and can take various actions like isolating the device, informing the home administrator to remediate the device, and several such actions, which makes it quite compelling that the owner of the device is now aware that his IoT device is infected. Next slide, please. Coming to the protocols, I mean, DOTS has two primary protocols. One is the signal channel protocol and the data channel protocol. Signal channel protocol has been designed to work under extreme network conditions when the network is congested, and it's the primary protocol used for signaling mitigation requests to the DOTS server. The second channel is DOTS data channel. This is a management channel. It's an optional channel. It's used for creating aliases for your resources. Let's say you have a bunch of domain names. Rather than conveying all those domain names or IP addresses during your attack, you can create aliases so that that short form of alias could be sent in the mitigation request. It's also used for creating ACL rules within the DOTS server. For example, filtering several IP addresses which are typically used as launch pads for attacking the target server could be blocked by that, and you could also create rate limiting filter rules. So it's relying on the ACL that's already defined to instantiate those ACL rules either during the attack time or during the peacetime. Next slide. DOTS and signal channel is, as you guys can understand, that it's supposed to run during a constrained scenario where the network is congested, and probably the client may also be resource starved because of the attack traffic that is coming in. So hello. Hello. Hello.
We can hear you, Tier.
Can you hear me?
Yes.
Hey, sorry. Again, it crashed. So it's using CoAP. CoAP is designed for IoT devices, but we picked the protocol because it's very lightweight. It can run on both UDP and TCP. TCP is just picked for as a fallback mechanism. The primary protocol that it's supposed to run is UDP because of the network conditions. It mandates the use of DTLS for security, and 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 the way we are using CoAP is to use its non-conformable messages, which can be periodically transmitted and don't need any doesn't require as a reliable transmission mechanism. So that way, periodic signals can be exchanged between the DOTS client and the DOTS server. Next slide, please. In addition to picking CoAP, I mean, the data model for this is CBOR, Consensus Binary Object Representation. It was again picked because of its, it keeps the message size really small and the message need not be really fragmented. So that's the reason, in addition to CoAP, CBOR data representation was picked. Next slide, please. So if you look into the primary operations of dot signal channel, it runs both during the ideal time and in the attack time. Ideal time is when there is no attack on the network, and it's that time when the dot signal channel is established between the dot peers. It's also used for negotiating the CoAP message transmission parameters, and heartbeats are exchanged to keep the session channel alive. When an attack happens, and if the DOTS client detects that it needs help from the DDoS mitigation provider, it sends a mitigation request for a specific set of resources within the network that needs to be protected. And we have an interesting feature called it's a Deadman Switch, basically, which triggers mitigation on signal loss. So if the signal is disconnected between the client and the server, then the mitigation is triggered automatically. And as you can see nowadays, the attackers are changing the way they attack a network. They target a specific resource and then change the DDoS attack and target different resources within the network. So the client has to change the mitigation scope as the attack evolves, and the mitigation also has to adapt accordingly. And further, the server keeps sending the mitigation status update back to the client so that the client operational security team does know what's happening at the server side. The client also sends feedback, basically the efficacy updates, to tell the server whether it is able to block the bad traffic or not. And based on that, the server can change its DDoS mitigation strategies. If the DOTS client reboots, then it can also send to retrieve the active mitigations. And when the server informs that the attack has been successfully mitigated and the DDoS attack has stopped, then the client can send a request to the server to stop doing the DDoS mitigation. Next slide. Data channel, DOTS data channel is based on RESTconf. RESTconf is based on netconf, which is for basically configuring network devices with configuration data. We are using that for creating aliases for the resources in the network, and for installing ACL rules to either permit, deny, or rate limit traffic either during the attack time or during the peacetime. Next slide, please. DOTS data channel, unlike signal channel, is designed to work only during the ideal time. It uses TCP. The first operation is for it to establish a channel with the DOTS server and then register the client. And then the client discovers the ACL filtering capability of the server. We have several ways where to synchronize the state with the DOTS server, to remove any stale entries, to remove any stale ACLs, or any stale domain names that were created, for which aliases were created. There are two parts of the management. One is the alias management and the ACL policy management. The aliases is just for resource creation, creating aliases for resources, and it's just a CRUD operation to create, delete, and update, read those aliases that were created. The second one is very interesting one, that it helps to create ACL rules across administrative domains, that now an enterprise network can tell an ISP to block a specific set of blacklisted IP addresses which are targeting the enterprise network, and it can do a very similar operation to create, delete, and update these ACL rules. Next slide, please. We have several documents in the working group. The two primary protocols have recently been standardized, the dot signal channel and data channel. The DOTS architecture and other drafts are already in the RFC edited queue. We have a requirements draft, and the use cases draft is in ISEC review. The open source of DOTS is available at this link, so if anyone wants to give it a try, they can explore this further and contribute to the open source. Next slide. Yeah, if you have any questions, you can send a mail to the DOTS mailing list.
Yeah, and I guess if there was one question now, we might have a little bit of time, but we are pretty much at the time slot. I do not see anyone who has managed to find the join the queue button quite yet. So I think we're going to say that questions can go to the mailing list, as you said. So thank you again. It's pretty exciting to see this stuff. All right. So Roman, can you get us back to the other slides? And looks like I am up next. So I had started a bit of a thread about this on the SAAG list. It's sort of the trigger. I guess we should go to the next slide. The trigger was an NFS document, actually, and one of the working group members made this sort of assertion that TLS fingerprinting is needed. And my initial response was that I didn't really think that that was the consensus position of the IETF security area, but I also didn't really have something that I could point to back me up for that. So I figured I should come here and ask and actually get a better sense of what our position is. And just to note that in this linked message, they were proposing 4 different options that all implementations should be required to support, which would be to sort of manually configure which key fingerprint or certificate fingerprint to use, to do the sort of pinning of the identity fingerprint, but also ensure it changes up to a trusted CA, and to have just a sort of typical PKI setup where you've got 1 or more CAs and anything that changes up to them you will accept. And also the option to just do a manual config, which I guess I skipped over when I was first reading them. So the sort of overarching question that I had for the group is, like, is this true, or when is it true if it's only sometimes true? So next slide. And of course, to just explicitly call out, this is not just about the web. For NFS v4, that's not expected to be using the web PKI with the CAB forum and whatnot. So please keep that in mind as we're having a discussion. Next slide. And thanks, I adjusted the slides a bit based on the traffic already on the list. So thanks to everyone, and especially to Ecker for sort of inspiring this bit of a taxonomy, just to try and make sure that we're actually talking about the same things when we use the different words. So it's important to call out the sort of manual configuration option, which would be just like configuring an entity asymmetric key or potentially even a symmetric key for some protocols. And you could do that directly, or you could sort of do the trust on first use, which imports it into your configuration when you first see it. I'm going to talk about like a public PKI, which would be something like the web PKI, where there's a large set of CAs that are sort of trusted by many people that are not of a common administrative boundary. You could also have sort of a more local PKI or enterprise PKI with basically like one CA that you control and may not extend beyond the administrative domain. And then also just mention that you have the DNSSEC option, which is not really going to factor much, I think, into the rest of the discussion, but just to list it there. Next slide. So I tried to summarize like reasons why you might pick the broader public PKI, or perhaps just a PKI in general. So of course it's a scalable option. You only have to configure the anchors, and then the anchors can sign through the tree structure many things, and you don't have to know about all of the end entities in order to be able to have a secure trust path to them. This, of course, makes the key rotation on the end entities easier because they just have to get a new thing signed by the same CA, and all the people who are talking to them don't have to update. You could also import your enterprise CA into that, but it does have the problem that these CAs are sort of high-value targets, and so you have to protect that. And depending on what kind of local deployment you have, you may or may not be prepared to protect that high-value secret very well. Next slide. And so that leads to some of the other options, like if you just do a manual configuration or a trust on first use setup, it's a lot simpler. You don't need to have these third-party CAs that you have to trust. If there is an enterprise CA in play, you can sort of bypass its ability to man in the middle of you if you don't want that, if that's the sort of setup that you're in. If you're in a PKI that you're obligated to have the enterprise CA in, but there's a particular application that you don't want it to be able to snoop on, then sort of the manual configuration definitely avoids that. And your revocation story is different, in some ways perhaps worse, because you're not you don't have a guaranteed path to find out about revocation or compromise. But the scaling is not so great. You have to sort of manually configure for all the systems you talk to. So it's got sort of a different profile of features and weaknesses. Next slide. And then based on the new taxonomy that we came up with, the pinning would be to sort of have generally the public PKI, and then you want to say, well, for many things, I'm going to trust all of the CAs in the public PKI, but for this particular thing, I want to pin to just a subset of the CAs, because in some sense, some of the CAs are less trusted than the others, but they're trusted sometimes, which is perhaps a little bit of a weird setup. And I don't have a great sense for how common this is, that you would need this sort of partially trusted state outside of the web PKI. And so the other updates that came out from the email are that we generally are not going to be recommending pinning to the end entity itself, because that's kind of brittle. I have this note about RFC 7469 no longer recommended. That maybe came out of the thread. If it really is no longer recommended, we might want to have someone consider writing a document to say move to historic. I tried to put that as a footnote, couldn't figure out how to do that. Anyway, next slide. So I have 2 slides of questions that I sort of want to get resolved by the group or to seed the discussion. And I don't know that we have to cover them in a particular order. People are free to jump into the queue if they see something that they want to opine about. But sort of the overarching question is relating to different protocols or types of protocols, just to say, like, when might we want to use a full PKI? When might we want to use just manual config? Probably the question of if pinning, what to pin, I sort of answered on the previous slide. And Roman, if you could go to the next slide, just got, I think, 1 or 2 more questions. So getting back to the original inquiry, do we actually want to be saying anything at all to require or encourage particular protocols to be robust in terms of what configuration options they offer? Do we think that just the ability to have a local PKI instead of a public PKI is enough? Or do we just want to say this is just implementation? We don't need to say anything at all about it. So that is how I want to see the discussion. It looks like we have maybe only 3 minutes left if we stick straight to the agenda, but hopefully we can be fast.
Wes, I have you in the queue. You're up.
Yeah, thanks. I actually thought I was second, but that's okay. So to answer the first question, yeah, I think, I'm always in favor for having everybody have the ability to, configure their crypto. And so if you don't do that, then you're not helping the clueless users. But going back to, I think one important element of your problem is that you're not defining who is doing the less trusting. In other words, who wants pinning and who wants config, because there's very different parties there, and what they want is different. Clueful users, of course, want absolute control. That makes sense. Clueless users don't have any idea, right? They're letting somebody else make the decision. You mentioned that OS and browsers But there's two other big parties. The CAs don't trust each other. They're all the best. They'll all tell you that they're the best and that you should prefer them over anybody else. Cert owners also don't trust things, right? Cert owners are the ones that want the pinning but want to be able to move too. They only trust their CA because their CA is the best. But then how do they move? So if you take this problem in all of those different viewpoints, you'll get very different answers, I think.
That's good insight. Thanks. I think Richard is going to be up next.
Sorry, Richard, I got confused between a heap and a stack.
No, that's all right, no problem. Yeah, I'm just going to reiterate what I had said on the list, which is very briefly that this is almost not a protocol issue. If you look at like TLS, MLS, and IPsec, various other protocols, the authentication stack is pretty loosely coupled to what's actually in the protocol. There's, TLS, for example, can handle both raw public keys that you have to manually configure and various types of PKI. So I think the question here is how to handle protocols that try to explicitly profile themselves down to only supporting one of these. And there it seems like we probably don't need an absolute prohibition, but we certainly need some justification of how, if you're going to constrain yourselves down to manual provisioning, why that's an acceptable option for something that's going to deploy in the internet. Like, how are you going to deal with the setup problems, the trust establishment problems around provisioning, and how are you going to deal with revocation?
Sure. Like, it becomes more plausible if your scope constrained to an enterprise as opposed to the full internet anyway, but you still have to answer the question.
For example, yeah. Yeah, I think, just to be clear, I think in my ideal world, like every protocol would follow the kind of TLS, MLS path and be agnostic as regard to its authentication platform.
Sure.
But in case where you want to nail it down, like you need to justify that.
Yeah, let's try and move on to next in the queue. So I think Ecker, you're up.
Yeah,
right,
so
a
few points. DKG or me, one of the two.
Go ahead, Ecker.
Okay.
I'll follow you.
Sounds good. So yeah, I guess a few points. Richard, it's true that ComSec protocols tend to be agnostic about authentication, but of course the underlying application protocols are not. So for instance, HTTP specifies how you want to do sort of certificate authentication. I think part of the question, so I think this does go back to a great extent to a use case, which is if you want, as I said in my note, if you like want to have a client or an entity which can talk to any entity in the universe, you're going to need some kind of public PKI, because or DNSSEC or whatever, some sort of publicly verifiable namespace. If what you want is and as I said in my note, pinning is really just a attempt to narrow the public namespace based on the preferences of the authenticating party. And as I said, this is like largely, I think, fallen out of favor in the web community. If you have a private setup, then I think the question is how many how many entities do you need in the system before like really manual configuration effectively becomes automatic configuration, which really is just sort of a goofy form of PKI. And I expect the answer to that number is very, very small.
Thanks.
This is DKG. Just wanted to observe 2 points here. One is that I believe that the IETF, we continue to skate around the question about whether we're doing APIs. This looks more like API than protocol design. But I want to state my support for it. I actually think that thinking clearly about what the API should be gives us a way to provide really good guidance towards the whole implementation community. And I don't think we should consider it out of scope. So I think thinking clearly about what the API needs to be for any certificate stack is a really useful thing. Secondly, I wanted to note that the term pinning has a history of multiple uses, including not just I want to constrain to this, but I also want to allow additional. And I think it's a little bit unclear whether we're saying both of these.
Yeah, I tried to
be. So there's a terminology issue here, and I maybe we want to just like claim that we own the word pinning and we're going to use it the right way in this one way, but there's a history of other documents that use it in other ways. So it's just something to watch out for. I don't have a specific suggestion for how to fix it.
Yeah. I was trying to set the stage for what we're talking about today and not trying to claim any claim on future terminology. Thanks.
Hi. So when we were doing HPKP and WebSec all these many years ago, we initially had all the different pinning ideas, pinning to end entity and pinning to CA, and finally we got to the conclusion that pinning the end entity is the wrong thing to do, because the keys do have to be replaced. Hardware fails, everything fails. You scale up, you scale down. So it makes much more sense to pin to the CA than to the end entity. And we wanted to take it entirely out of the RFC, out of the draft, and we finally left it as a not recommended option. But the thing you want to pin to is the CA, not the end entity. Now, granted, this info was coming from Ryan Sleevey, who was working at Google, and when they say something doesn't scale, they mean something different than all the rest of us, but still, end entities do get replaced and keys get replaced, and then you have to reconfigure everywhere where it's configured, and you don't want to do that.
All right, thanks. So we are actually 5 minutes over time at this point for that topic. So Phil, if you could drop your comment to the Jabber or the email, we'd still have to hear from you, but we have to move on to the next topic at this point, which is the BCP 72 updates for the security considerations guidance. And we've got a couple things sort of in flight that may be making changes or updates sort of in this general space. We've got Fernando's document about the security considerations when you have numerical identifiers in your protocol. You probably saw on the SAG list, I've been having a little bit of a back and forth with my AD evaluation comments, but I think we are converging onto something useful. And I want to have a bit of extra visibility to SAG about what we're actually doing in the document, especially with the big questions about, are we making requirements or just adding to the list of things to think about in terms of what guidance we give. And then the other sort of high-level question relates to how much detail we go into in the document. If we just need to sort of give a general list of the topics to consider, or if we should really go into more detail and give examples of how these come into play, or if we should leave that to some of the other documents that are in progress. So please go pay attention to the email thread and chime in there if you have thoughts on that topic. I don't know that we need to have a big discussion on that today. Thanks, Roman. Forgot about that slide. So here's the threat model IAB program is also underway, and they've been having some discussions. So I believe we got a couple of slides from Yari to talk about what was going on there. So Yari, please take it away.
Yeah, can you hear me?
Yes, I can hear you.
All right, so this is one particular aspect of this broader BCP update discussion. So just the Model T part of it. I had 2 slides. I'm just gonna cover the what's happening in Model T and then talk about potential updates. And the Model T, of course, is about extending the set of threats that we should consider more carefully, basically because we had great success in deploying some security technology, and now the threats are migrating to other things, or I mean, the threats or vulnerabilities were always there, but now the other side is attempting to use other aspects or other avenues when we're plugging the more obvious avenues. And of course, when we discuss about these other things, we are not trying to reduce the importance of communication security protection in any fashion. So that's totally out of scope. And of course, since we have an IAB program, we're not about to override what the IETF says about various things in its BCP. So we might make some suggestions individually, but that's the end of it. So we've had basically 2 kinds of discussions, documents and discussion that talks about the threats, various issues, new or old, and design guidelines at various levels, and a bunch of documents. You see some of them. I probably missed a few, but you see the list of drafts on the screen. And then we've also talked about these potential suggestions and that we would take to the IETF at some point, and this could be one such point. Some additions to existing PCPs, particularly 3552 or 7258. And then one that I would like to highlight today is the first one. If you go to the next slide. And just to set the stage a little bit, so this is something that we, or some of us at least, feel that should be done. We're not wedded to a particular set of words in any fashion. Just felt that we should write some words so that we can get criticizing them, or we could replace them with better words, or whatever the process is. But we did write some words, suggestions, and the draft that we have with Stephen does add a few pieces of text. There's like the high-level thing that's sort of highlighted, the yellow in the middle of the screen, and then there's a few other parts, basically one paragraph each, in most cases at least, further on in the document. The idea, of course, is that the BCP 72, it shouldn't be like your kitchen sink guidelines, that everything that you ever needed to know about protocol design and security, it should not be there, but you should perhaps recognize some high-level issues. So we did feel that it would be useful to talk about the other endpoint compromise, or how you limit the effects of compromise, how you could potentially force or remind people that you should try and force active attacks, and worry about traffic analysis, and what techniques can you use to contain the compromise of various trusted parties. The details are in the draft. I don't think we have time for that part really today. Please comment on the list. It'd be nice to get some feedback.
Yeah, and just to point out, this is an open membership IDB program, so anyone can sign up and remind us how to do so.
Indeed, we have a mailing list, and we also have a get-together today at 1610 UTC. I don't want to do the math.
Basically after the last session, yeah.
Yeah, and the coordinates are in the mailing list. So if you look for model-T mailing list from the IETF mailing lists, you'll find the relevant emails.
Thanks. It's exciting to have people thinking about this and try to be more precise about what the best practices are. I think we should probably roll any questions or comments about this into the general open mic. So I guess we have a slide that says open mic, but yeah.
Yeah, I was going to say, I think this rolls to the last part of our agenda. We have a couple minutes for open mic.
Yeah. Or if there are no open mic topics, we can retire to gather.town and have our Hawaii conversations a few minutes early. Going once, going twice. More traffic in the Jabber, but not coming to the queue. All right. Thank you very much, everybody. We appreciate all the comments here and on the list, and we will see you virtually.
Thanks, everyone.
Thanks.